What up, dudes? Can you hear my voice? All right, can you see my face? Well, no, you can't see my face, but can you see my computer screen? Good, let's get this party started. So check this out. I'm going to do a warm-up problem, and let's do this one. 3x squared minus 8x minus 16. Okay, so this is one of those things where you have a number in front of your x squared term. And I'll be honest with you, those are just straight up a pain. Like, it's a pain in the butt. Let me see, did we solve this problem already? No, I guess not. All right, whatever. All right, it's a pain in the butt to do because, I don't know, it's just, there's no real, exact, steps to factor this thing. You just kind of got to try. What's nice about this is, well, Sophia, you're asking, can I factor out a 3? What you're saying is, can I pull a 3 out of here? And the answer is no. I can't pull a 3 out of the 8 or the 16. That's, yeah. If I could, that would be nicer, but I can't. So, it's not, so then I have to deal with this 3. I'll be honest with you, it's not so bad when there's a prime number in there because you have something like a 3x and an x. And you know it can't really look anything else besides that. So when the number out here is not a number that can be factored a whole lot of different ways, then it's not as bad. But when you have something like 4x squared minus 5x plus 7 or something like that, I don't even know if this can be factored. I guarantee you it probably can't. But you could have 4x and x. You could have 2x and x. And that becomes a pain in the butt to deal with. Okay? So at that point, I wouldn't factor at that point. I would use the quadratic equation or quadratic formula as you're mentioning, or completing the square, which is what we're doing today. But for now, let's just back out. Delete all this stuff. There we go. All right, let's finish this problem. So I see a minus here. That means I know that I'm going to deal with a plus-minus situation. Now in this case, I can also do a minus plus. And because there's a leading coefficient of a number that's bigger than 1, that does make a difference, plus minus or minus plus. I still know that the bigger negative number is going to go on the is going to be the overall number will be negative, but it's a little bit deceiving here. So what numbers multiply out to be 16? Well, I can go 4 and 4. But if I did 4 and 4, let's see. Here's the thing about 4 and 4 is if I did 4 and 4, I need the difference to be 8. So I'll have 3 times 4, which is 12. I'll have 4 times 1, which will be 4. Can I mess with the numbers 12 and 4 to get the number 8? Yes, awesome. Actually, I think we just got it right off the bat. Lucas is saying you can try 2 and 8. Well, let's think about that, though. Is if we use a 2, maybe an 8 over here and a 2 here, 2 times 3 is 6. 8 times 1 is 8. I can't mess with the numbers 8 and 6 to get the number 8. So these guys are out. You see what I'm doing here? I'm just going through and seeing. No, Bradley, you're right. The answer is 4 and 4. Absolutely. But I'm showing you why I'm disregarding that 2 and 8 in my head. Obviously, if I get the answer, if I'm doing this homework, I get the answer right off the bat, then I would just be like, well, I'm done. I'm going to keep moving on. But I'm showing you folks what's going on in my head. And sometimes it takes a long time, especially when it's my head. If I use the numbers 16 and 1, so I could do a 16 here and a 1 here. But when you multiply the 3 times 16, that gives you a really big number. I'm not even going to calculate it out. I just know it's big. And a 1 times 1, which is a small number, 1. So can you mess with the 1 and this really big number that's 3 times 16, I think it's like 50 something, whatever, to get the number 8? And the answer is absolutely not. Not even close. You see what I'm getting at here? So see this number in the middle, since it's a smaller number, I'm going to choose factors that are relatively close to each other. And in this case, I would use 4 and 4, as we've discussed. Because what you're going to do is this middle term over here really comes from the outers and the inners multiplied and added together. You multiply the outers with the outers and the inners with the inners, and then you add them together. Now, which one is it? Is it this one or is it this one? I don't know. I can tell you that actually it's the first one, because 3 times negative 4, this outer part, is negative 12. 4 times 1 is positive 4. And the bigger one I want to be with the negative number. And I want it to be because it's negative 8. So I'm going to say that this thing right here is the factored form of what I'm looking at. Does that make sense to you? All right. If I were looking for the zeros of this equation, I can easily say, all right, 3x plus 4, okay, this is wrong. 3x plus 4 equals 0, or x minus 4 equals 0. The right-hand one tells me that x is equal to positive 4. The left-hand one tells me I can go 3x equals negative 4, and then x is equal to negative 4/3. Also known as negative 1.3333 whatever. Making sense? So if I were to graph this thing, it would graph right at negative 1.3, so it'd be like somewhere around here. Positive 4, 1, 2, 3, 4. I know the y-intercept is negative 16, so way down here. And it would graph something like that. Oops. All right, and then let me see. Do I have a nice calculator I can pull up? Yeah, sure, all right. So let's take a look at this thing. We'll reset it. And then what was the equation again? It was 3x squared minus 8x minus 16. Wait a second. I'm a little confused. Hold on. Here's what I'm confused about. Is this looks like an upside down parabola to me. Doesn't it? Oh, no. Never mind. This is perfectly fine. This is a happy face parabola. This 3 should be positive. I'm sorry. For some reason, I was thinking that this was an upside down parabola. I'm crazy today. Just forgive me. Hold on. Let's take a look at the graph. Oh, okay. Let's zoom out a little bit. All right. Well, let's zoom in real quick. Do you see the x-intercept happens at 4 and also negative 1 1/3? Let's take a look at that y-intercept. Instead of zooming out, I'm just going to trace it down. Going down, going down. There we go. And if you look at where it crosses the y-axis, it's at negative 16. So look, without using a graphing calculator, we were able to guess what the graph looks like. I think that's pretty amazing. Don't you? All right, so that sums up chapter 3. Let's move on to chapter 4, because I know I covered that with you. Does anyone have any last questions, vomits, etc. on chapter 3? This is your last opportunity to ask them, unless you do special tutoring with me, which, by the way, I'm holding special tutoring on tomorrow from 7 to 9. You can come in or you can go online. And I'm basically just doing open tutoring. I don't even have a plan as to what I'm going to be tutoring on. You can just ask me questions. Asking me to fix homework, all of that kind of stuff. I'm going to try to shy away, though, from giving out answers to homework. That's not always fair for me. All right. All right, questions, comments, vomits, etc. Moving on to chapter 4. So, let's try this one. Given that x squared minus 5 equals 0, solve for x. Okay, I think the only lesson that we're trying to teach you here is to remember this plus or minus thing. First thing I'm going to do is add 5 to both sides. So I have x squared equals 5, positive 5. 1 second, I've got Sharon Abrigo calling me. Hello? Yo. Oh no, biology. I'm actually in class right now, but you can ask your question. Oh, Celeste is a biology major. She'd be a great idea. Yeah, all right. Celeste, they called me about a biology question, and I threw you under the bus, and I said, Celeste is a biology major. She can help, because I have... You do not want me to teach your future doctors. They will kill people. Okay. Sorry about that, folks. They asked me a biology question, and I said, the other teacher over there, look at her. Okay. Yes, you can. I can teach future doctors. I'll just teach them engineering and physics and stuff like that, and then we'll leave the biology stuff to the biology people. I'm so scared of biology. Man, I can't stand blood or anything. I'm a wimp when it comes to that. Anyway, moving on. By the way, if this were x squared equals to 4, and I'm changing the problem a little bit, but if this were x squared equal to 4, what would the answers be? There we go, Bradley. You would take the square root of both sides, and you would say x is equal to plus or minus 2, because the square root of 4 is 2, but you have to throw in that plus or minus. Same deal here. If you take the square root of both sides, x is equal to plus or minus the square root of 5. Now, I'm going to let your calculators answer that and figure out what the square root of 5 is. I'll show you folks real quickly my technique of figuring out what the square root of something is. All right, first of all, you know that the square root of 4 is 2. You also know that the square root of 9 is 3. The square root of 5 has to be a number that is in between 2 and 3. And I guess the question is do you think it's closer to 2 or closer to 3? Okay, my answer is I think that it's closer to 2, and so I would say about 2 and a quarter, or maybe let's see, 4. Let's 5, 6, 7, 8, 9. So there's 5 spaces. I would say 2.2. That's my answer. So x is approximately equal to plus or minus 2.2. What is the actual answer, by the way? Use your calculators. What's the square root of 5? $2.236. I got close. Okay, moving on. All right. Let's do their quick dog and pony show thing. That's, I don't know why I called it a dog and pony show. I'm gonna make a new document. Don't save it. Just make a new one for me. All right, let's try this. 3x squared minus 12 equals 0. So 3x squared equals 12. I added 12 to both sides. X squared is equal to 4. How did I do that? How did I get x squared equals 4? I divided both sides by 3 because this 3 is being multiplied. All right, there we go. Then I square root both sides, so x is equal to plus or minus 2. And if you were to graph this, 3x squared minus 12 graphed would look something like this. Oops. Let's reset the window. How do I do that? I'll just zoom out. There we go. If you were to graph it, it would look like a parabola like that. And where does it cross the x-axis? At plus or minus 2. So, ergo, we got it correct. Because that's essentially what we're doing here. Alright, that's example 2. Let's look at this one. This one looks harder. Sure. Why don't we look at this one? This one looks harder. Alright. 3x minus 2 squared minus 48 equals 0. Getting you used to solving quadratic equations that are already in completed the square form. All right. The way I tell my son how to solve for x is I tell him, I'll tell you a quick story. And did I tell you the Thor story already? I think I did. Right, talking about the Thor trying to get his hammer, pulling off the layers. No, I didn't? Oh, okay. All right. I'll tell you the quick story. You ready? Do you remember that scene in the first Thor movie where he lost his hammer and he was trying to get his hammer back? Do you remember where he had to go in and he had to fight all of these people? Yeah. So there's like these layers, right? His hammer's right here. But it's being guarded by this big African American dude. And then that layer is being guarded by like a bunch of people out here. And for some reason, the facility, the shield facility he had to break into looked to me like a big hamster cage. I don't know. I don't know why. It just looked like a giant hamster cage. And there was a chain link fence on the outside. Got it? So what Thor had to do, here's Thor, he had to go in and beat up all of these guys. Well, first of all, he can't beat up those guys. He has to break through the fence or jump over it or whatever. But he has to get through the fence first. And then he has to beat up all of the guys on the outside. And then he has to go into the hamster wheel thing. And then he has to take out the big African-American dude. And Hawkeye's up here somewhere just kind of hanging out. I have no idea. He never does anything in that whole movie. But finally Thor gets to the middle of the Tootsie Pop and is able to grab the hammer. Does that make sense? Like you've seen this... some of you have seen this before. If not, some of you can imagine this. But what I always tell I think I thought I was teaching you this because I taught this to my 6th grade son like a month ago. I taught the same thing to my 6th grade son. And I said, if you want to get to the hammer, you have to pull off the layers, and you have to pull them off in order. You cannot go straight for the African American dude or go straight into the hamster cage without first getting through the chain link fence and beating up the guys on the outside. Because the guys on the outside, if you're going straight after that African-American guy, the big pro wrestler-looking dude, those guys on the outside are going to come in and beat you up. And then you're going to be outnumbered, and that's a bad thing. So you have to peel these layers off one by one. Well, this is what I tell him. I said, look, son, X is in the middle. And it's being guarded by this minus 2 times 3, the square of, oh no, it's the minus 2, the square, the times 3, and the negative 48. And you have to peel those things off in layers. So the outermost layer, the chain link fence of our problem is the 48. So I simply add it to both sides. The reason why I'm going through this with you is because maybe a lot of you know how to solve for x really easy, and I apologize if I wasted your time. But some of you, a surprising amount of you, have trouble solving for x. And so I basically just went through the Algebra 1 rendition of how to solve for x. Now, did I tell you this story yet? The Thor one? I feel like I did. Oh, okay. Well, it's a good story. All right. The next outermost layer that we need to peel off here is the 3. I tell my son that it has to do with proximity, like how close it is to x. And this square over here is actually closer than the 3. And that 3 is being multiplied. So to get rid of it, obviously, you divide by 3. Divide by 3. X minus 2 squared is equal to 48 divided by 3. What is 48 divided by 3? Is that 16? Sophia, let me answer your question in just a second. Yeah, it is 16. Awesome. All right. Now I square root both sides, and I have x is equal to, or I'm sorry, I didn't get rid of that minus 2. X minus 2 is equal to plus or minus 4. Why the plus or minus? Because I took the square root of both sides. Whenever I take the square root of both sides, you need to throw in a plus or minus in there for good measure. Not for good measure, but you understand why, right? Because it crosses at 2 points. All right. The last piece of information is I need to solve for x. So I have x is equal to 2 plus or minus 4. And this is really two separate equations. This is x is equal to 2 plus 4, or x is equal to 2 minus 4, which is two separate answers. One is x is equal to 6, or x is equal to negative 2. Okay. Sophia asked me a question. I thought it was an interesting one. Does it have to equal to 0, or can it equal a number? And my answer is this. What if I had this? Minus 42 equals 6. What if I had this over here? The same kind of thing, but instead of a 48, I have a 42 and I have a 6 over here. Then then what I would do is, maybe if I'm used to seeing the right-hand side equal to 0, I would subtract 6 from both sides. And that would give me 0 on this right-hand side. But it would give me 48 over here, and it would be the same exact problem. So I guess my answer is, if it's not equal to 0, then make it equal to 0, if that's what you feel like you're comfortable with. We cool with that? But I'll be honest with you, you can't make it equal to any, like just any old number. Like I can't make this a 3 or something like that, because I had to choose a number that nicely took a square root. But that's not always true, because you might have a non-nice square root, a decimal, and then you just deal with a decimal. All right. All right, moving on, because I don't have a whole lot of time. I feel like I run out of time, and I think it's probably because I tell too many of those stupid stories. Vertex form. Now check this out. This is actually pretty cool. 3x squared minus 48. All right. What does the 48 do? Let's say it's equal to f of x. What does the 48 do? It moves it's the y-intercept, and it also takes your parabola and pushes it down how much? 48. Very good. Okay. This 3 over here, what does that do? We've talked about this. This isn't a trick question. It's the same one. It vertically stretches, exactly. And it also makes it a happy or sad one. And so we were looking at ax squared plus bx plus c equals f of x. And we went into great detail about what the c does and what the a does, and we didn't really figure out what the b does. And I know Bradley kept on asking me questions about that, and I did kind of show you, and I said, that one's a little tough for the bx squared whatever, because it kind of, Bradley's guess was it moved it right and left, And my answer was, it kind of does it, but it also moves it up and down along this, according to this parabola-looking thing, and it's weird. But look, check this out. I'm going to show you a different form. So this is standard form. We also have factored form, which is like x minus x, or x minus d times x minus e equals 0, or something like that. And that's this. These things are the same thing, just wearing different clothes. They look different. Got it? Now what I'm going to show you how to do is do a parabola that is actually really nice. Let's do this. Let's go with, write this down, okay? X, I think it's a times x minus h squared plus k equals 0. Write this down. Okay, this is standard form. This is factored form. And this right here is called vertex form. All right. This k right here, what do you think that does to the parabola? It moves the vertex up and down. Exactly. Very good. I mean, and it looks just like our C, right? And this A over here, what do you think that does to our parabola? The slope, no. Yes, exactly, Sophia. It does the exact same thing that it does in all the other cases. It vertically stretches it, it vertically compresses it, or it makes it a sad face, or it makes it a happy face. It's the same exact variable. So, yeah, because I wrote the same variable, you would have assumed that it does the same thing. Now, this is the thing that Bradley was looking for when he was asking, oh, is that what moves it right and left? Well, I'll tell you what. I'm going to teach you by showing you a bunch of examples. And I apologize because I'm already over time. I'm late already, and I know you have an appointment. You can leave if you want to. I'm archiving this. And I'm going to start chemistry class a little bit late because I want to finish showing you this. Let's look at this. Let's do this. I want to graph a nice, easy parabola. All right, there's our nice, easy parabola, right? And we're used to seeing, we know what the 3 does, we know what the -4 does. But what if instead of an x, I replace it with an x minus 2? What is going to happen to that parabola? And I'll tell you what I'll do is, what is going to happen when I put an x minus 2 inside of that parentheses? Okay. Sophia says the vertex becomes 2, -4. Okay. Explain that to me in terms of pushing this parabola around. Because I can tell you what this k does. It pushes it up by 4, and in this particular case, it moves it down by 4. Is it going to push it to the right by 4? Is it going to push it to the left? Or this 2 over here. Is this 2 going to push it to the right by 2 or to the left by 2? Sophia says to the right by 2. Why do you think that, Sophia? It's a -2. I'm just saying. So Lucas is changing his mind, and he's saying, okay, wait, well, so I would change my mind and say, well, yeah, I would say it goes left. What do you folks agree? Do you guys agree with Sophia or not? And Sophia, are you changing your answer? Or, I mean, it's up to you. Aha! I haven't been able to trick you. Sophia's absolutely right. Here's what I did is I graphed both parabolas. I graphed the standard one before we added the -2, and then I graphed this. I graphed this new one right here, and when we graph it, you can see that it took this parabola, this regular parabola that we're used to, and moved it to the right. The reason why I'm such a jerk about trying to trick you on that one, is because a lot of students always tell me that this -2 means moves it to the left too, and I could see the intuition in that. I can completely see where you're coming from. You know what I mean? But it does the opposite of what you would expect it. Since this -2 in here, it actually moves it to the right 2 units. If there were a +2, it would move it to the left 2 units. The opposite of what you would think. Moving things to the right and left are a little bit funky, but it's actually just opposites. It's opposite day in terms of that. So to compensate for that, we added in this negative number. We added in that negative to compensate for that extra weirdness. I'll tell you what, we'll explore this more on Wednesday, but I really want to get to chemistry, so I'll talk to you folks later.